Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 9 to the power of x equals 18. So what I'm first going to do is I'm going to take the log of both sides. So now we have log 9 to the power of x equals log 18. So if we have something in the form log a to the power of x, this is known as power property, and what it means is that we could actually move this exponent in front of the log, meaning this would also equal x log a. So I'm actually going to change log 9 to the power of x into x log 9. And this is equal to log 18. Now, if I divide both sides by log 9, these two cancel out, and I would get x is equal to log 18 over log 9 is the same thing as log 9 times 2 over log 9. And now if I distribute the log to both of these terms into parentheses, get x is equal to log 9 times log 2. And we are still dividing this by log 9. And sorry, this is actually a plus. So now this is equal to log 9 over log 9 plus log 2 over log 9. Now these two cancel out, so we get x is equal to 1 plus log 2 over log, and I'm actually going to replace the 9 with 3 squared. Now remember, we're going to use the same property that we used over here, and I'm going to move the 2 to the front. So I'm actually going to move it right over here. So if you plug in log 2 into the calculator, log 2 is actually equal to approximately 0.301. And log 3 is equal to 0.4771. So now if I plug in these numbers, we would get 1 plus log 2 is 0.301. over 2 times log 3, well, that would be 0.9542. Now, if you divide these two, you'd get x is equal to 1 plus 0.3154, and 1 plus this would be 1.3154. So this is our answer. Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 81 to the power of x equals 27 to the power, we have 81 to the power of x minus 27 to the power of x equals 0. Now what I'm first going to do is I'm going to change 81 to 3 to the power of 4. So I'm going to replace 81 with 3 to the power of 4. So now we have 3 to the power of 4 to the power of x minus, now I'm going to change 27 to 3 to the power of 3. So now we have 3 to the power of 3 to the power of x. And this is equal to 0. Now, if we have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. Meaning 3 to the power of 4 to the power of x, well, this would equal 3 to the power of 4 times x, or we could also write that as 4x, minus, now we're going to do the same thing over here, 3 to the power of 3 to the power of x. This is the same thing as 3 to the power of 3 times x, which is simply just 3x. Now this is equal to 0. Now I'm actually going to add 3 to the power of 3x on both sides. So now we get 3 to the power of 4x. These two cancel out, equals 3 to the power of 3x. Now, because these two bases are the same, this also means that the exponents here are the same as well, because if we have a to the power of b equals a to the power of c, this means that b is equal to c, meaning 4x is equal to 3x. So now if I divide by 3 on both sides, I get 4 over 3x is equal to x, meaning the only value that would fit this would be 0. So x is equal to 0. And as you can see, if we plug 0 in for this equation, we get 81 to the power of 0 minus 27 to the power of 0 equals 0. And anything to the power of 0 is 1. So we get 1 minus 1, which does equal 0.